On a dark September night in 1931, the British fishing boat Calinda was dredging the bottom of the North Sea, 40 kilometres offshore. What they brought up with the catch would transform our view of the planet that we call home. A lump of freshwater peat with a 20-centimetre harpoon head stuck inside, carved from the antler of a red deer. That's a strange thing to find in the ocean, and strange things call for further investigation. Over time, other prehistoric objects dating from the Mesolithic period have been recovered from those dark depths, in fishing nets and by marine archaeologists searching the sea floor. Tools, weapons, and the remains of animals such as mammoths and even lions. How did all these things get there? Well, there's only one logical explanation for this. That part of the sea floor, now 40 meters below the surface, was once dry land, a place covered in vegetation, and people lived there. You've probably heard of Atlantis, the mythical ancient land that disappeared under the sea. Well, thanks to recent advances in mapping technology that can see deep under the oceans and even under the ocean floors, scientists really are discovering lost lands, and not just small islands like Atlantis. They have found whole continents that could be treasure troves of minerals and fuels to power our future. I'm James Stewart, and you're watching Astrum Earth. In this video, we'll explore continents you may never have heard of. Continents that have disappeared under the water, have been crushed into fragments, and have been dragged down under the Earth's crust. Lost continents that hold the keys to understanding this planet in which we live. The vanished land where that barbed spearhead was discovered has now been mapped and is called Doggerland after the Dutch boats that fished this part of the North Sea. But nearly a century after that discovery was made, we still know less about what lies beneath our oceans than we do about the surface of the moon. But geologists are beginning to understand how the continents that make up our planet are changing over time. We like to think of the land we stand on as something solid, something permanent, but that is actually not the case. On the other side of the world from where the Calinda was dredging the sea floor, lies Zealandia, a continent twice the size of India, 94% of which is currently underwater. Only the islands of New Zealand, which are just the very highest parts of a vast mountain range, poke out above the surface. The rest of it has shrunk, a whole kilometre down beneath the waves. We still don't know how much of this lost continent was once dry land, and until very recently, we didn't even know that Zealandia existed at all. The search for a large continent hidden in these waters goes back a long time in history. In 1642, the Dutch explorer Abel Janszoon Tasman discovered New Zealand, previously unknown to Europeans. Even though Australia was already known, they believed that there must be another large continent on the opposite side of the world. A large land that would balance out the mass of Europe and keep the world stable. And it was this land that Tasman was sent to discover. What he found was the South Island of New Zealand, not the large continent that he had been looking for. Perhaps he was disappointed with his discovery because he never set foot on this new land. He did, however, give his name to the Tasman Sea between New Zealand and Australia. It took 375 years until we came to understand that Abel Tasman had in fact discovered his large continent. So how was it possible for Zealandia to go unnoticed for so long? The answer is in fact simple. It is very difficult and very expensive to explore what lies at the bottom of our oceans. Oceans cover 71% of our planet, yet most of this enormous area remains unexplored. The outline of Zealandia only became visible once satellite technology allowed mapping of small variations in Earth's gravity. One other thing that may have hindered discovering lost continents is that until recently, we didn't have an agreed definition for what a continent actually is. It's an area or a kind of landmass, right? But that's pretty vague. So to classify as a continent, you firstly have to be a large continuous geological area with a high elevation. Secondly, you need a wide variety of rocks. And thirdly, you need a thick crust. This differentiates a continent of varied rocks that is 20 to 40 kilometers thick from more recently formed sea floor, which tends to be entirely igneous rock and much thinner, typically less than 10 kilometers thick. Analysis of satellite imagery and of rock samples from the ocean floor allowed GNS Science, a leading New Zealand research institute, to confirm in 2017 that Zealandia is a true continent separate from Australia. Very little is yet known about it, but that's not entirely surprising because it's a huge area to explore, almost the size of Australia and in very deep water. You may be familiar with the movement of the tectonic plates that make up Earth's continents, and how they've moved around the surface with time, how they are still moving. But the picture that is now emerging appears much more complex. As these continents slowly drift around, they are pulled apart, opening new oceans, and they're forced together, creating vast mountain ranges. Mountains such as the Alps and the Himalayas seem astonishingly high to us, but in reality, the surface of our planet is almost completely smooth, as it's constantly pulled into shape by the force of gravity. If smooth isn't the word that comes to mind when talking about our planet's surface, let me compare it to a football or a soccer ball. On that scale, our highest peak, Mount Everest, would be less than the size of a grain of sand. The oceans that cover most of the surface of our planet would be no thicker than a layer of plastic food wrap. It's all a matter of perspective. Admittedly though, things from our point of view are more dramatic. As the continents drift around the surface of our planet and are pushed into each other, this gravitational pull causes parts of the crust to sink, and in a seesaw effect, other parts rise. In addition to all this movement, climate change causes ice ages that last for tens of thousands of years, which means that vast quantities of the planet's water becomes locked in glacial ice. The warming of our planet then causes the ice to melt and flood into our oceans again. Following a warming period around 18,000 years ago, sea levels rose by 120 meters. All around the globe, huge areas of land have gradually disappeared under the sea. There is more to this story than just rising sea levels though. As our planet cools and warms, this affects the stability of the Earth's crust and the way it floats on the thick layer of magma that makes up most of our planet. If we go back to the North Sea, or rather the sea floor, where our story began, we can imagine what it would have been like there on the day when a hunter lost one of his most prized possessions, his hunting harpoon. As he followed his prey, the land beneath his feet was as solid as the ground you or I set foot on when we step outside our front doors, unless you live on a houseboat, of course. There were mammoths and deer to be hunted, as well as cave lions that roamed these lands. As the planet warmed, the herds of animals moved north to graze on new fertile pastures, and the people who hunted those animals moved north with them. But when the hunter dropped his harpoon, the land beneath his feet was far from stable. It was moving, and it keeps moving even today. This part of the Earth's crust is still recovering from the vast weight of ice that pressed it down during what we call the last ice age. Despite us still being in an ice age that began about 3 million years ago, and technically speaking, we are merely experiencing a warmer interglacial period. As the global climate changes, cooling and then warming again, the ice caps grow or shrink. and the enormous weight of all this ice affects the land underneath. The north of Britain, for example, continues to rise, while the south is slowly sinking, a process known as glacial isostatic adjustment. Since London was established as a major city by the Romans 2,000 years ago, it's sunk by more than a metre and is still sinking, while Scotland, on the other end of this slab of the Earth's crust, continues to rise out of the sea. Far to the north of our hunting man, Scandinavia was rising out of the magma upon which the thin surface crust of our planet floats, and it keeps on rising. The port of Tornio on the border of Sweden and Finland has had to be moved downriver at least twice as the land rises and the sea retreats. This is a worldwide phenomenon. New York City is slowly sinking, while further north at Bathurst Inlet in Canada, an amazing series of raised beaches has been left behind as the land continues to rise out of the ocean. Around Antarctica, similar effects are seen as land masses rise or fall, recovering from the weight of the vast amount of ice that 20,000 years ago pressed this part of the Earth's crust down into the mantle by as much as half a kilometre. New technologies such as high-precision GPS monitoring reveal that the surface of the Earth recovers much more quickly from the loss of melting ice in Antarctica than it does in the Arctic. A 45mm rise was recorded in just 1 year. Now that may not sound a lot, but over a century, that's almost the height of a 2-story house. The ground beneath your feet is not just moving, it moves at different rates depending on where you are. The main reason the hunting ground once walked by our ancestors disappeared beneath the North Sea is not because of the moving Earth's crust. It's due to the rise in sea levels since all that ice melted and flooded the oceans. Doggerland is still there, it's just hidden underwater, unlike the former continent known as Greater Adria. This is a continent that has not simply vanished beneath the waves. It has been entirely obliterated and dragged down underneath what is now southern Europe. New geological methods are beginning to reveal the story of a continent the size of Greenland that has completely disappeared. Parts of it are believed to have sunk 1,500 kilometers below the Earth's surface, and all that remains are some surface rocks that were scraped off as it was consumed into the Earth's mantle. So what happened to Greater Adria? How can we just lose a continent? To understand that, we have to remind ourselves of where all our modern continents came from. And the accepted theory is that they formed from the breaking up of a huge supercontinent we call Pangaea. The name is from ancient Greek, Pan meaning everything or all, Gaea meaning Mother Earth. This supercontinent was formed from all the other continents coming together, in a cycle that seems to repeat itself about every 500 million years. Continents have formed, reformed, and disappeared ever since the outer crust of our planet cooled and solidified. Beneath the surface, our planet is molten rock, which is far more solid than the fiery red gloopy lava that we see pouring out of volcanoes when they erupt, but still moves like a boiling liquid. The heat within the Earth's core drives thermal currents that flow beneath our feet, and the movement of this viscous mass drags the surface crust along with it, causing what is known as continental drift. The same process that brought all the earlier continents together to form Pangaea then started to break it up again. It was ripped in two, forming two supercontinents, Laurasia and Gondwana. These were separated by a vast sea that no longer exists, called the Tethys Ocean, running east to west, unlike our present Atlantic and Pacific Oceans that divide the continents north to south. This difference in orientation will play into our story later. Laurasia would later break up to form North America, Europe, Asia, and at least one more continent that we will come to later. Gondwana, much larger than Laurasia, drifted down towards the South Pole and broke up to form South America, Antarctica, Australia, India, and Africa, and the recently discovered Zealandia and Greater Adria. As those land masses drifted apart again, they were dragged to different parts of the globe by the powerful currents of magma flowing underneath them. When something the size of Africa begins to move, nothing is going to stop it. And so, the world was about to witness the brutal murder of a continent. It might have been a part of our planet's geography for a long time before it was pulled in with all the other landmasses to form Pangaea. But when Gondwana and Laurasia broke apart again to form the continents of today, Greater Adria was doomed. It became stuck between the colliding continents of Africa and Europe. Thanks to groundbreaking work at Utrecht University in the Netherlands, we now know that Greater Adria was first pushed into an area roughly where the Mediterranean Sea is now. It was then spun round counterclockwise as Africa bore down on it from the south, and it was trapped against Europe to the north, shattering into pieces due to the unstoppable forces of the two enormous continents coming together, like a small speedboat getting squashed by a large freighter on either side. Subsequently, it began to sink as both Europe and Africa were forced upwards over the smaller landmass, driving it down into the mantle. The ocean that separated Africa from Europe was sliding under the Eurasian tectonic plate, a mechanism known as subduction, and it looks like it simply took Great Adria down with it. Now, Great Adria has vanished completely underneath southern Europe. So little remains of this lost continent that it's difficult to say what it was like. Was it a single enormous island covered in life, or completely submerged beneath our oceans? The team at the Department of Earth Sciences at Utrecht University have concluded that at least part of it was underwater. Some of the rocks that were left behind were limestones deposited in a shallow sea, but others are volcanic, suggesting reefs or a chain of mountains. They believe there were likely a string of islands, but there could have been a much larger landmass that we may never know about. This enormous geological pileup that created the Alps is ongoing. Earthquakes and volcanic activity around the northern Mediterranean remind us that things we cannot see are happening beneath our feet. As the African continent continues its unstoppable journey northwards, eventually the whole Mediterranean Sea could disappear, and lands that we are familiar with today could be sucked down into the mantle, or crushed and forced upwards to make the Alpine mountain range even bigger. Italy, Greece, and Turkey could be wiped off the map. There is another lost continent, one that took scientists decades to find using a combination of logic and literally groundbreaking science. Did you know that the force of gravity is not always the same as you move around our planet? It varies according to several factors, particularly the thickness and density of the Earth's crust. Just such a gravitational anomaly had been noticed around the islands of Mauritius, an island country in the Indian Ocean, 2,000 kilometers off the southeastern coast of East Africa. Here, the gravitational pull is exceptionally strong, which suggests a large mass somewhere between the islands. This led geologists to start looking into the rocks around Mauritius, particularly new volcanic rocks that can reveal secrets about what lies deep under the surface. In those rocks are crystals called zircons. They are radioactive and can therefore be used to measure the age of the rocks in which they are found. They discovered that rocks that were being thrown up to the surface during volcanic eruptions were billions of years old, but the rocks that make up the overlying landmass are only about 8 million years old. New ocean floor crust is being created all the time from magma as continents move apart, but the zircons that geologists found in the volcanic rocks of Mauritius are older, much older than anything that could have come from newly formed crust. In geological terms, Mauritius is a recent formation, and it must be sitting on top of something very old, meaning it could only be above ancient continental rock. They had found another lost continent. The history of Mauritia is only now being pieced together, and again, it's a story of violence and destruction. Fossil evidence tells us that after Gondwana split up, a land bridge allowed animals to walk between Madagascar and India. But Madagascar can now be found off the southeast coast of Africa, while India has moved 5,000 kilometers northeast, where it crashed into the Eurasian continental mass, an impact that is still creating the Himalayas. At some point, and for reasons we do not yet understand, that land bridge that we now call Mauritia was torn apart and was dragged down beneath the ocean floor. It's now disappeared completely, but fragments of its compressed and heated rocks are brought back to the surface during volcanic eruptions. How large Mauritia was and how much of it is spread out beneath the floor of the Indian Ocean is still a mystery. 10,000 kilometers away on the edge of the Arctic Circle, a geological treasure trove could lie beneath the waves, believed to be yet another lost continent. Very much like Zealandia, it is a large continental mass with only the islands of Iceland visible above the surface. So yeah, you've guessed it, that continent is called Icelandia. Although it could tell us a lot about the world that exists beneath our oceans that we know so little about, the discovery has already become controversial. For a long time, we assumed Iceland to be no more than a volcanic rock formation that has erupted out of the sea floor. Geological data, however, has never fitted well with that theory. For example, the crust underneath Iceland is 40 kilometers thick, which is what you'd expect from a slab of a continent, not from recently formed ocean floor, which is more typically only around 6 kilometers thick. This and other geological anomalies arouse the curiosity of scientists. A team led by Gillian Folger, Professor of Geophysics at Durham University in the UK, now believes that Iceland sits above an enormous tectonic plate of continental crust that stretches from Greenland to Europe. If this turns out to be correct, then the way in which the former supercontinent of Pangaea is believed to have broken apart will have to be reconsidered. But that's not what's so controversial about this theory. The discovery of Icelandia is hugely political and is being discussed in corridors of power across the globe. If it can be proved that Iceland sits on an enormous seabed that's an extension of their continental landmass, the country could be granted exclusive rights by the United Nations to the mineral resources contained in that area. Continental crust is where all our minerals are found. Just as Doggerland, or what is now part of the North Sea, was once dry land, Icelandia could once have been dry land too, rich with forests and swamps, the conditions in which fossil fuels such as oil and coal are formed. New ocean crust does not contain these sources of hydrocarbons, but if areas of the ocean floor are found to be former continental landmass, well, that changes our view of what might be hidden down there. Many of the recent discoveries about Doggerland were made during surveys for offshore wind farms, driven by our understanding of the need to move away from burning fossil fuels as we place ever greater demands on what our planet can provide, and even greater demands on what our planet can absorb. The discovery of a previously unknown continent that has sunk beneath the Atlantic Ocean could lead to exploration for new sources of fossil fuels, and the temptation to make use of them will be completely at odds with our need to pursue sustainable sources for the increasing amount of energy we need. There is a real risk that rapid exploration of our ocean floors will begin, for the purpose of nations claiming territories to be their own. Why does this matter? Well, if the oceans remain as international waters, there are strict controls about the use of their resources. This helps to preserve vast areas of our planet. If nations claim areas of this underwater wilderness and call it their own, they'll be legally free to exploit it, adding to the already overstretched burden that we place on the floating greenhouse in space that we call Earth. If recently discovered continents like Icelandia and Zealandia prove to be enormous sections of what used to be Pangaea, it will suggest that there are other lost continents to be discovered, and they too could be exploited for valuable resources. Our ocean floors would become political battlegrounds. Deep ocean mining is currently banned in international waters because the environmental impacts of this emerging industry are not yet fully known. But it could make nations rich, and we know from experience how hard it can be to prevent such exploitation. Our constant hunger for Earth's natural resources could start to destroy the ecosystems that depend upon our ocean floors before we even have any proper understanding of them. There is one last continent we want to talk about today. One with a huge landmass, bigger than Australia, that has been lost underwater. But one that you've definitely heard of. Hidden underwater that is cold and solid. Antarctica. Surprisingly, we know as little about the continent under those frozen plateaus and glaciers as we do about the other lost continents that we've looked at. Indeed, we know more about the surface of Mars than we do about the land under the Antarctic ice. Only very recently, researchers at the University of Durham have been able to analyse the results of satellite imagery and ground-penetrating radar to build up a picture of what Antarctica, the continent, is like. It's revealed a landscape of mountains and valleys formed by rivers, now remodelled by the ice that has covered the continent for more than 30 million years. The coastline of this hidden terrain is very difficult to determine, because while sea levels would rise should all that ice melt, the weight of the Antarctic ice sheet is also pushing the landmass down into the ocean. And nobody knows what it might look like once all this geological upheaval settles down. 90% of the world's ice and an astonishing 60% of all the world's freshwater is currently locked away on Antarctica. This makes it very difficult to find out what's hidden beneath this frozen covering, which in places is nearly 5 kilometers thick. What we do know about Antarctica, though, is how it's moved around the surface of our planet over time. As sediments are laid down on our continents, and volcanic rocks cool and become solid, they trap a record of the Earth's magnetic field. By analysing this stored data from samples around our continents, geologists have been able to reconstruct a picture of where all the land masses were in relation to the magnetic poles over time. This geological detective work has revealed that Antarctica was once further north in a warmer climate, before taking up its present location over the South Pole. It's not always been frozen under ice as it is today. Fossilised plant records found on Alexander Island on the west coast of the Antarctic Peninsula show that Antarctica was once covered in forests, probably similar to the temperate forests found in Patagonia today. So why is it now this cold? It's partly because the planet has cooled, but mainly it's because Antarctica's lonely isolation covering the South Pole is responsible for its own frozen existence. Let me explain. Do you remember how Pangaea separated into Gondwana and Eurasia and the Tethys Ocean opened up between them? That ocean ran east to west, unlike our present oceans that separate the continents from the north to south. This is hugely important in terms of our planet's climates. The separation of the Atlantic and Pacific Oceans creates powerful thermal currents that run north and south, and they distribute heat from the equator around the planet. Ocean currents that run from west to east have the opposite effect. They actually prevent the sun's heat from spreading north and south from the equator. When South America and Australia moved north, away from Antarctica, they opened up the Drake Passage and the Tasmanian Gateway, allowing the ocean to flow freely around Antarctica. Strong winds driven by the Coriolis effects, a force caused by the rotation of our planet, circulate around Antarctica. These strong winds cause the cold water at the perimeter of Antarctica to flow in a powerful and endless stream called the Antarctic Circumpolar Current. This prevents warmer waters from further north from reaching Antarctica, keeping the freezing cold waters trapped around it and imprisoning it in ice. The positions of all our continents and the seas that flow between them have an enormous impact on the wide range of climates found on our planet. If Icelandia and Doggerland had not sunk beneath the oceans and had remained as an extension of the European landmass, the climate of the Northern Hemisphere would be vastly different from how it is today. The warming water currents that heat up much of Europe would not be able to flow through the Atlantic Ocean. Large areas of Europe and North America would be much colder. The Arctic could even develop an enormous permanent ice cap similar to that over Antarctica. It seems such a small difference whether these lost continents remain above the oceans or not, but their impact on the rest of the planet would be immense. If Greater Adria had been pushed upwards over the European continent instead of being subducted underneath it, there would be no Mediterranean Sea, possibly no sea there at all, and the area now covered by much of Europe could have been an arid desert similar to the Sahara. The varied climates that we see on our planet today are dependent on the continents that have formed over millions of years. If large landmasses like Zealandia and Icelandia had not disappeared, the world would be a very different place. Discovering these lost continents allows us to imagine all kinds of different worlds that could exist if the tectonic plates that move around our planet's surface had behaved just a little differently. But there's a serious side to this too. It raises questions of politics and creates arguments between nations over who has the rights to newly discovered resources. It would be incredibly sad to begin destroying those hidden continents as soon as we've discovered them, and before we even properly understand them. So we need to decide how to move forward as an international community, and we need to think about better ways to obtain and make use of the minerals that may be found under our oceans. Be it sunken, crushed, or frozen over, it's crazy to think how long these continents went unnoticed. And it raises the question of how many more are waiting to be discovered. Despite our species having inhabited our planet for hundreds of thousands of years, we clearly have so much more to learn about it.